All right, let's dive right in. Today we're talking about a tool that's about to completely change how we write React apps, the new React compiler. Seriously, think of it like an autopilot for performance. It just automatically optimizes your code so you can get back to building amazing features. And to kick things off, let's start with a question I think every single React dev has groaned about at some point.
Yeah, I see you nodding along. If you write React, this question probably hits a little too close to home. How many hours, honestly, have we all spent meticulously wrapping functions in use callback and values in use memo? It's always felt like this necessary chore. But what if it just wasn't?
And that's the real problem, isn't it? Manual memoization is not just boring, it's a total minefield. It clutters up our components with boilerplate. It's a pain to maintain. And as we're about to see, it's shockingly easy to mess up, even when you're sure you've got it right.
So here's our game plan. We'll start by really digging into that memoization headache and see how the new compiler is basically the cure. Then we'll get practical. We're going to cover how to install it, how to roll it out safely in a real project, and of course, what to do if you hit a snag.
Okay, first up, let's really unpack this shared pain point, the memoization headache. This is all about the thankless chore of manually tweaking our React components just to make them perform well. So take a look at this code. It should look incredibly familiar, right? We've got our component wrapped in React.memo. Inside, we're using useMemo for some heavy data processing and useCallback for a click handler. It's the classic playbook for manual optimization. It feels right, but man, just look at all that extra code. But here's the kicker. Even after all that work, this code is actually broken. And this isn't just a hypothetical. The official React team points out that this exact kind of code often has a tiny, subtle bug that completely undoes all of our hard work. And the bug is something we've probably all done. You see it? It's that little arrow function we create inside of a map during the render. Every single time this component renders, a brand new function is created. That means our React.memo wrapper sees a new prop, thinks something has changed, and re-renders. All that effort, completely wasted.
And this right here is exactly the problem the React compiler was built for. It's designed to just lift this entire burden off our shoulders so we can get back to the fun part of our jobs, actually building cool stuff.
So what is the React compiler, really? Well, it's a build time tool. That part is crucial. It's not running in your user's browser. It scans your regular, plain old JavaScript code, and because it understands the rules of React, it automatically adds all the necessary memoization for you. You write less code, not more. And this just says it all. On the left, you've got our tangled, buggy, manually memoized component, and on the right, clean, simple, easy-to-read JavaScript. That's what your code looks like with the compiler. You just write the logic like you normally would, and the compiler does all the heavy lifting in the background. And here's the best part. The compiler is smart enough to optimize this correctly. It automatically sees and fixes that sneaky little arrow function bug we just talked about. It makes sure your components only re-render when they absolutely have to. So it's not just easier, it's actually more reliable than doing it by hand. Okay, so you're probably sold on the why. Let's get into the how. Getting this thing up and running is way more straightforward than you might think. Let's walk through installing it and making sure it's actually working. It really boils down to two simple steps. First, you just install the official Babel plugin. Just make sure you grab the release candidate by using the @rc tag. Second, you just pop that plugin into your build config, whether that's a babel.config.js file, your Vite config, or whatever your framework uses. Now, listen up, because this is the #1 gotcha you need to avoid. The React compiler plugin has to be the very first plugin in your Babel pipeline. No exceptions. It needs to see your raw, original source code before anything else gets a chance to transform it. Get this one detail right, and you'll save yourself a world of pain. So how do you even know if it's working? Well, the React DevTools give you this awesome little confirmation. If you pop open your DevTools and see Memo with a little sparkle emoji next to your component name, that's it. That's your seal of approval. It means the compiler did its job successfully. Now, I know what some of you are thinking, especially if you work on a huge legacy code base. The idea of adding a new compiler can sound, scary. But the React team built this thing for us with safety and gradual adoption baked right in. Let's look at 3 ways you can roll this out. The most important message here is you do not have to flip a giant switch and compile your entire app overnight. In fact, you shouldn't. The whole idea is to start small. This lets you build confidence in the tool, measure the impact, and handle any little code cleanups in a totally manageable way. So you've got 3 main strategies to choose from. First is directory-based. You can just tell Babel to only compile files in certain folders. This is perfect for trying it out on new features. For even more control, there's opt-in mode. You just add a use memo string at the top of a file, and only that file gets compiled. And for the real pros, you can use runtime gating with a feature flag to A/B test the performance impact in production. Pretty cool.
Of course, in the real world, things don't always go perfectly. So let's talk about your safety net. What do you do when you run into issues, and how do you figure out what's going on?
Okay, first, and this is the most important thing to remember, the compiler is designed to fail safely. If it looks at a component and can't figure out how to optimize it with 100% confidence, maybe you're doing something weird that breaks the rules of React, it won't break your app. It'll just quietly skip that one component and move on. But what if a component does get compiled, and then it starts acting weird? Well, you have an escape hatch. It's your break glass in case of emergency button. You just add the string use no memo to the top of that file. This directive tells the compiler, hey, back off, leave this one alone, which gives you all the time you need to debug without blocking everyone. So, if you do hit an issue, here's the mental checklist. First, ask yourself, was my code accidentally relying on use memo for things to work at all instead of just for performance? That's a classic anti-pattern that can cause things like infinite loops. To find out, just use no memo and take out your manual hooks. If the bug is still there, you've probably got a rules of React violation, and the official ESLint rule is your best friend for hunting that down. Okay, let's wrap this all up. What are the big takeaways? The React compiler automates all that boring memoization work and can even fix bugs you didn't know you had. The key is to start small using one of the incremental strategies. If you get into trouble, use no memo as your safety valve. And all along the way, keep an eye out for that little memo Sheng badge in your dev tools to make sure it's working.
And that leaves us with one last big question to think about. With a tool this smart, this safe, and this effective, a tool that can literally do the job better and more reliably than human can, is it finally time to start thinking of manual memoization with use memo and use callback as a React anti-pattern? Food for thought. Thanks for joining me.